Okay, welcome. And now we're going to do a checkpoint. So here's what we're going to do. Again, you want to sketch this graph. So remember, go through the properties of both functions, find out how it behaves, right? And then, you know, the damping factor, right? Also, make sure you plot a couple of points on the graph in the y-intercepts on both sides so you get an idea, and then sketch the graph. Okay, so to make sure you follow that procedure. Even though in the last example I just kind of drew it out, again, I'm going to go through the process of sketching it because this is what I expect you guys to do. So, okay, go ahead and pause. Go ahead and sketch the graph using what you know, and come on back and see if you get the same thing. All right, here we go. So I'm going to see here our damping factor is x squared, just like before. Okay, and then we're dealing with sine of 4x. Okay, so again, I'm going to go through the behaviors of this graph. So we know x squared is a damping factor, and it behaves, it's a parabolic curve. Okay, so again, we're going to have something where we have x squared, which is always positive, or excuse me, non-negative, right? And then we've got sine of 4x, which bounces between 1 and -1, right? So we know, based on the behavior of these two graphs, this is going to bounce between what? X squared and the opposite of x squared, or negative x squared. Okay? Now the only thing we have to know is when is this going to touch the graph, right? So it's either going to equal x or negative x when what? When sine of 4x is equal to 1 or -1. Okay? So when is sine of 4x equal to -1 plus or minus 1? Well, remember, when is 4x equal to pi over 2? Okay? When is 4x equal to pi over 2? Well, 4x equals pi over 2 plus n times pi when what?
Call from B.
When what? When x is equal to pi over 4. Or excuse me, pi over 8. Plus or minus.
Call from B.
N times pi over 4. Right? Because if n is 0, we get pi over 8, and then 4x equals pi over 2. If n is 1, we get pi over 8 plus what? Pi over 4, which is the same as 2 pi over 8, and we get what? 3 pi over 8, and if we plug it in here, we get what? 3 pi over 2. Okay, and so on. So that's when it touches the curve, right? X squared or negative x squared. Now, when is this equal to 0? So when are the x-intercepts? Where do they occur? Well, remember, they're going to occur when sine is equal to 0. And again, sine x is equal to 0 for every multiple of pi. So when is 4x equal to pi? So 4x, oops. So I'm just going to write this out a little bit. So 4x equals what? Some multiple of pi when what? When x equals a multiple of pi over 4. Okay? Because when it's a multiple of pi over 4, the 4's are going to cancel here. When you plug it into x, the 4's are going to cancel and you get a multiple of pi in the sine function. So that's when we're going to have the x-intercepts occur. Okay, so now let's sketch this graph. Okay, so okay. So if I do this, actually, well, yeah, it's going to be tough to plot this way. Okay, so now at x equals pi over 8 and x equals pi over 4. So let's go by fourths. So pi over 4, pi over 2. Okay, I'm just going to do this. Okay, so that's what we have. And so at pi over 8, it's going to touch. So pi over 8 is going to be up here, right? And then down here, it's going to be down here. And then it's going to be up here. Like so. And then here. Something like that. And then it's going to cross at so fourths. Right? So it's going to cross here. So it's going to look something like this. Oops. Oh. All right. Let me know if you got the same thing or something different.